Good day! For today's discussion, we will learn about solving problems involving permutations and combinations. At the end of our discussion, I hope that you will record the basic concepts such as steps in solving problems and factorial notation, classify problems whether it involves permutation or combination, and solve problems involving permutations and combinations. Before we start the discussion, let us recall what is a permutation and a combination. Permutation refers to the different ways of arranging a set of objects in a sequential order or order does matter, while combination refers to several ways of choosing items from a large set of objects such that their order does not matter. For now, let us give the examples for permutation and combination. I have here set A, so we will choose if this set A or given examples in set A is for permutation or combination. Number 1, determining the top 3 winners in a math quiz B. Number 2, assembling a jigsaw puzzle. Number 3, class officers' elections. Number 4, opening a combination lock. And number 5, entering your 6-digit PIN of your ATM card. In our 5 given examples, does the order matters or do not matters? It is a permutation or a combination? Correct! The answer is permutation. How about in set B? So I have here number 1, choosing 5 questions to answer out of 10 questions in a test. Number 2, selecting 6 students to form a students' affair committee. Number 3, drawing a set of 6 numbers in a lottery containing numbers 1 to 55. Number 4, listing the parts of a circle. And number 5, choosing 2 household chores to do before dinner. In our 5 given examples, does the order matter or do not matter? It is a permutation or combination? Correct! The answer is combination. Before we answer problems involving permutation and combination, let us recall the basic steps on how we can solve problems. So, another key concept that you must ponder before solving word problems are the steps in solving problems. So let us recall the steps. Number 1, analysis. So, before you answer the given problem, you will read it and analyze. Number 2, required. It is knowing what is asked in the question. Given, it is the step that presents the given value or values in the problem. And after knowing what is asked, what is given or what are given, next thing that you will have to do is to know the formula, because it is the step that provides the number sentence or the formula to be used in order to solve the word problem. And of course, we need to show or compute for the solution. It provides the procedure on how the answer is achieved. And the last is the answer. It is the last part of solving word problems. The answer must be suffixed with unit or measurement or denomination, or it is a problem solving, so our answer must have its unit of measurement, whether it is inches, meters, kilometers, and many more. Or it has an label. Before I will give examples in problem solving involving permutation and combination, let us recall the concept of factorial notation, because it is also important to remember this because we are going to solve permutations and combinations. So it is denote by n factorial is equal to n multiplied by the difference of n and 1 multiplied by the difference of n and 2 and so on up to 1. So here are the following examples. So number 1, 3 factorial is equal to 3 times 2 times 1 is equal to 6. Number 2 is equal to 5 factorial plus 2 factorial. So the answer is 122. Example number 3, 9 factorial, and it is equal to 362,880. Number 4, the difference of 10 and 3 factorial is equal to 7 factorial, and 7 factorial is equal to 5,040. And number 5, again, 0 factorial is equal to 1. So, please always remember this. 0 factorial is always equal to 1. Let's start with problem number 1. You are asked by your teacher to arrange the letters in the word mathematics, regardless of each word's meaning. In how many ways can you arrange the letters in the word mathematics? So let us follow the steps in solving problems involving permutation and combination. So we have here number 1, analysis. So the problem involves blank of objects. So it is permutation or combination. Very good. The answer is permutation. Next step is what is being asked or what is required. So in here, it is seen or usually seen by the last part or last sentence of the problems. So the answer is number of ways I can arrange the letters of the word mathematics. Next to what is being asked is the given. So in problem number 1, the given is the word mathematics. So we have 11 because mathematics has 11 letters. Our fourth step is what formula we will use. So we will use the formula of indistinguishable permutation or permutation with identical object. So the formula is permutation is equal to n factorial over p factorial multiplied by q factorial multiplied by r factorial. Let us continue to solve problem number 1. So next to formula is the solution. Again, we will use the formula of permutation with identical object or permutation with indistinguishable items. So we have here permutation is equal to n factorial over p factorial multiplied by q factorial multiplied by r factorial. So the value of n here is 11 because the word mathematics is composed of 11 letters. And then we have here in our denominator 2 factorial multiplied by 2 factorial multiplied by 2 factorial. So again, in the word mathematics, you can see here that the letter M is written twice. Or we have 2 letter M, so it is equal to 2 factorial. We have 2 letter A, so it is for another 2 factorial. And as you can see here in the word mathematics, we have here 2 letter T, or T is written twice. So again, in our denominator, we have 2 factorial multiplied by 2 factorial multiplied by 2 factorial. So let us now simplify. And you can see here, again, it is division, so we can cancel here 2 and 1. And we can divide this number 10 to number 2. Or you can divide the denominator 2 by 8, 6, or 4. So you will choose 1, so I will choose 10. So it is equal to 5, and this is equal to 1. And, okay, we can cancel here 8 and 2. So again, you will choose numbers from the numerator that is divisible by 2. So you can cancel 6 or 4. So I will choose 8. So this is equal to 4. And this is equal to 1. So the remaining numbers in our numerator is 11, 5, 9, 4, 7, 6, 5, 4, and 3. So we are going to multiply the number or the remaining numbers in the numerator. So what is the answer? Correct. The answer is 4,989,600. And our last step is our answer. So in our answer, we must include its label. So from our solution, we have here 4,989,600. So what is the label? Ways. So again, you can see here that our final answer is 4,989,600 ways. Are you ready to solve problem number 2? Great! So here is the problem number 2. You are given 5 sets of word problems to solve. Your teacher instructed you to use only 3 problems from the given set. How many combinations of word problems are possible? So step number 1, you will analyze. So this problem involves permutation or combination. Correct. Combination. Second step, what is being asked? Correct. The number of possible combinations of word problems. third step, what are the given? So, there is a total of 5 word problems to choose from. You are required to solve 3 word problems. After the given, what is the formula that we are going to use? Correct. It is combination of n taken r is equal to n factorial divided by the difference of n and r factorial multiplied by r factorial. Now, let us show the solution for problem number 2. So again, we use here the combination formula, which is combination of n taken r is equal to n factorial divided by the difference of n and r factorial multiplied by r factorial. So by substitution, the value of n here is 5 and the value of r is 3. Again, in permutation and in combination, the value of n is always bigger, or n is always greater than the value of r. So by substitution, we have here 5 factorial over the difference of 5 and 3 factorial multiplied by 3 factorial. So first is to get the difference of our denominator, 5 minus 3 factorial. So we have here 5 factorial over 2 factorial multiplied by 3 factorial. Simplifying 5 factorial, we have here 5 times 4 times 3 times 2 times 1. Same with our denominator, we have here 2 times 1 multiplied by 3 times 2 times 1. So we can cancel here 3, 2, and 1. And you can see here that we can simplify this. Number 4 will become 2. 4 divided by 2 is 1. And 4 divided by 2 is 2. So 2 divided by 2 is 1. So the only remaining number in our numerator is 5 multiplied by 2. So what is your answer? Correct. So the answer, combination of 5 taken 3 is equal to 10. And our last step, from our solution, the answer is 10. And then, what is the label? Correct. We have here 10 combinations. Let us continue to solve problem number 3. Ashley was given 6 sets of books, namely English, Mathematics, Science, Filipino, ESP, and MAPEH by her class advisor. She wanted to arrange them in her bookshelf. In how many ways can she arrange the books? Number 1 step is to analyze. So in here, it is a permutation. It involves permutation. What is being asked? So, the value that is to be solved in the problem is the number of ways Ashley can arrange her books in the bookshelf. Given 6, which is the total number of books Ashley has to arrange. And the formula that we are going to use is permutation of n taken r is equal to n factorial over the difference of n and r factorial. Let us continue to solve the problem. After the formula, which is permutation of n taken r is equal to n factorial over the difference of n and r factorial, we can now solve and show our solution. So in here, the value of n and r is 6. So it is equal to 6 factorial over 6 minus 6 factorial. And if we are going to simplify, permutation of 6 taken 6 is equal to 6 factorial over 0 factorial. And always remember that by definition, 0 factorial is always equal to 1. So in here, we can only have 6 factorial over 1 or 6 factorial. And if the value of n and r is the same or equal, like here in our example or in our problem number 3, the value of n and r is equal or the same, it is the factorial notation of itself. So 6 and 6 is equal to 6 factorial, so it is equal to 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. What is our answer? Very good. Permutation of 6 taken 6 is equal to 720. And our last step is to write the answer with the label. So final answer is 720 ways. Are you ready to solve problem number 4? Great! Mrs. Pascual is instructed to appoint 5 of her 5 students to fill in the positions of class president, vice president, secretary, treasurer, and auditor. If she has 30 active students, in how many ways can she appoint her class officers? So first step is to analyze. So this is about permutation. And what is being asked? It is the number of ways Mrs. Pascual can appoint 5 students to fill in the different officership positions in her class. What are given? So the given values are 30, which is the total number of Mrs. Pascual's active students, and 5, which is the number of class officership positions to be filled in. And the formula that we will going to use is permutation of n taken r is equal to n factorial over the difference of n and r factorial. Let us show our solution to our problem number 4. Again, permutation's formula is permutation of n taken r is equal to n factorial over the difference of n and r factorial. And by substitution, we have here the value of n, which is 30, and the value of r, which is 5. So 30 minus 5 is equal to 25. So we have here 30 factorial over 25 factorial. And we can now have here 30 multiplied by 29 multiplied by 28 multiplied by 27 multiplied by 26 multiplied by 25 factorial. So I end it with the 25 factorial because the value in our denominator is 25 factorial. So I can easily cancel it. And the only remaining numbers in our numerator is 30 multiplied by 29 multiplied by 28 multiplied by 27 multiplied by 26. And what is our answer? Correct. Permutation of 30 taken 5 is equal to 17,100,720. our last step is our answer to that. So the answer is 17,100,720 ways. Let us now move on to problem number 5. In how many ways can 7 people be seated at a round table? So number 1, after we read the problem, we are going to analyze. And problem number 5 involves circular permutation since the main object is a round table which is circular form. So what is being asked? It is the number of ways can 7 people be seated at a round table. Given 7, which is the total number of people be seated at a round table. And what is the formula that we are going to use? So circular permutation formula is permutation is equal to the difference of n and 1 factorial. Let us continue to solve problem number 5. So our solution again, first is to write our formula. Circular permutation formula is equal to the difference of n and 1 factorial. So the value of n here is 7. So the difference of 7 and 1 factorial is equal to 6 factorial. So what is the answer? Let us see if you got the correct answer. So we have here 6 multiplied by 5, multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. And the answer is 720. Great! Very good. And in our answer, so it is 720 ways. Very good. Our last problem. Alyanna is crafting bracelets made of beads. She wants to sell them online and plans to use the profit in paying for the internet, which she uses for her online classes. In each bracelet, 8 big and colorful different gems are included. In how many ways can Alyanna arrange the 8 different gems in a bracelet cord in order for her to form different bracelets to sell? So number 1 is to analyze. So this problem illustrates circular permutation since the main object is the bracelet cord, which is circular when formed. What is being asked is the number of ways Alyanna can arrange the 8 different gems in a bracelet cord. Given, so we have here 8, which is the total number of gems to be arranged in a bracelet cord. And formula is circulation or circular permutation is equal to the difference of n and 1 factorial. So we have here the solution, and our circular permutation formula is equal to the difference of n and 1 factorial. So the given is 8, so the difference of 8 and 1 factorial is equal to 7 factorial. Now, I want you to compute for the answer. So 7 factorial is equal to 7 multiplied by 6, multiplied by 5, multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. So what is our answer? Great job! The answer is 5,040. However, we need to divide the answer by 2, since when we turn the bracelet 180 degrees, the positions of the beads are the same. So, will you please divide 5,040 by 2? And what is the answer? Very good. The answer is 2,520. And our final answer is Correct. 2,520 ways.